Hi, everyone. How are you doing? My name is George, and let's go to the next slide. Yeah. My name is George. I've been developing iOS applications since I can remember. I'm part of the foundation team here at Adidas. Was Rafa?
Yeah,
Uh,
my name is Rafa. Also working out with George in this foundation team.
Yeah,
Yeah, iOS developer as well,
yeah.
of course.
We're gonna we're gonna we're gonna talk about another important part of app development, which is build time improvements and how we are leveraging tools supplied by the community, like the amazing iOS community we have, to improve our build time. Hopefully, you learn something new, maybe get inspired, or most importantly, point out something we can improve in our system. So yeah. So if when we take a look at the application, the Adidas application, when we download it from the internet, it has to contain everything that is needed. A lot of files, assets, code, resources, and most importantly, translations. Think of it as a single container. When you open it, it needs to run properly. So it has to contain everything. And those things can be huge. In fact, just taking a look at the number of files we have, um, it shows how big it is. I mean, we have a lot of third-party libraries, but we're getting there. Ours is growing. And those files are not just there on disk. They are related to each other. They need to be compiled different ways. They need to be imported in different ways. And this can be complex in Xcode because Xcode doesn't help us a lot. So um, let's go back to the basics. We have two important components here that constitutes an application and that we deal with on a daily basis, whether we are a pro or we just started our iOS development journey. So the target and the project. The blue box here, this is a target. And it groups resources together under one purpose, as we know. So for example here, we have the product page target that contains everything related to the product page. And we have the checkout flow target that contains everything that it needs to properly go through a correct checkout flow. Now, normally, as those grow, we tend to split them to improve speed, improve architecture, and as we see here at the bottom, we have the networking core. And this is an example of one target that we have that contains some important things we use to contact our gateway or our APIs. And this is used by multiple different targets. The second component we have, which is another one would argue that it is the most important component you have in development, is the Xcode project. And this is a project file, which is the source of truth of your entire project. And it is important to keep it clean and uncorrupted. And this can be proved to be a bit difficult when you have multiple developers working on a single project and you have multiple configurations, and even more so when you have multiple apps, because each of this Xcode project will have to reference different files, different targets, and they will have to be built differently and dependent on each other in different ways. So it could prove to be challenging to maintain a big one. So for us, for example, we have at least 3. We have one project for every app, and that is it. That is it. We went back and saw what is a target and what is a project. Back to basics, and let's see where we go from here.
Okay, so now we're gonna take a look a bit at the challenges that we are facing when working in this big application that we have. So yeah, let's take a quick look at this. So yeah, as George mentioned, okay, we have this project that we need to have to configure everything in Xcode with all the files, the targets, so everything's in there. So when only one person is working in the project, and I can imagine that most of you, if you have like personal projects, when you are the only one working on the project, everything is fine, okay? You can make your changes there and it's gonna work. When you have multiple people touching this file, it's gonna be it's gonna get messy super soon. And I swear that you have faced this in your project. You have like multiple people working on it, and it is also something that we have experienced that sometimes this file gets corrupted, and you have to spend like a huge amount of time going through it because it is really difficult to to check what is going on there because it's not that trivial. It's not a common format that other people use there. So yeah, it's an Apple thing. Um, then yeah, regarding the targets, and now we're gonna talk about our dependency graph. We have like two different issues. So yeah, when you think about the image, the graph that we have in the left. So yeah, usually when you want to build, like for instance, the first node, the node A, uh, you don't really want to build everything that is in this dependency graph. You only want to build node A, but that's not how Xcode works. It could work like that locally, but it's not going to work like that in a CI/CD environment, for instance. And even locally, if you like trust the derived data as a cache for your nodes, that's not going to also work like every single time. And there's also an additional issue, which is that in this dependency graph, and that's the second image, nothing stops you from interconnecting the different nodes and basically messing up with the build system. And this is also an issue that we experience, that we start to connect some things with other things that didn't make sense. Basically, you screw up the build times. So yeah, basically, when you are in like a building pipeline, kind CI/CD environment, we have like this huge project that we have to load. We have like this dependency tree, which is huge as well, and that it takes quite a lot of time to build. So yeah, over 25 minutes in an M1 machine. And I'm gonna answer one of the questions that you did in the previous in Eduardo's presentation. So it's 25 minutes in total. We have like 4 different applications. We have the Adidas app, the China flavor, which is a different from the Adidas app. Then we have Confirm, and we have the retail application, which is something that we use for the iPads in the stores. And that takes over 25 minutes, and it will be like maybe between 8 and 10 minutes for the Adidas app, running both the app and running the unit test and the snapshot test. Around between 6 and 8 for Confirm. China will be maybe 5, 6, and then retail is 3, maybe 2, 3. For China and retail, we don't have any tests. Yeah, that's the way it is. So yeah, if every time we have to build all this app, it takes this amount of time. It's going to take a lot of time. It's going to make the developers super sad, and of course, it's going to cost us a lot of money. When you're working in your machine, your local machine, the developer experience is going to be the same. Okay, so you have to do all these things. You have to load the project, building the dependency graph, and the only thing that we have right now, or that we know, is basically to buy more powerful laptops, and that's it. Okay, it will solve for a while. Yeah, okay. But yeah, we don't want to build. We don't want to buy laptops like each year. We don't want to buy like the new M4 whatever M5 because there is no M4, just the iPad right now. But yeah, let's take a look at the solutions, and yeah, let's see what we can do here, okay, to try to mitigate all these problems. So first, starting with the project, and this is really simple, okay? So what we can do to resolve all these conflict issues that we have, it's super easy. Don't commit this file into your repository, right? And try to generate this file. And yeah, in our case, and well, this is something that Eduardo mentioned quite a lot, we use Twist for this. So yeah, we have all the configuration right as a code, as a Swift files, and yeah, we use that to generate the project file. And this is quite important because this step of generating the project from config files give us like the access to the dependency tree. And we are gonna build most of the solutions that we're gonna speak right now on this access to the dependency graph. So looking into the second issue that we have, which is like in this case, if you make like one single line change, you're gonna trigger like a field build, and you're gonna spend like 25 minutes waiting for a build to end. So yeah, how can we solve this? So yeah, here the idea is that, or the problem that we have is that imagine, okay, this is the Adidas app. We have the checkout and the product page, as George mentioned before. So we make a change in the checkout, and for whatever reason, we need to build everything, the product page include. And the question is, well, okay, why we need to build this? Why we need to build everything? So let's try to be smart, and let's try to build only what we have changed. And this is actually what we are doing. Okay, so we introduce like this caching step before generating the project. So now this will be like this. So instead of building everything, the full dependency tree, if we see that only the checkout has changed, we're not gonna build the downstream dependencies. We are only gonna build the upstream dependencies, and obviously this is gonna like save like quite a lot of time when you are building all the apps.
Yeah, but there is a small caveat about this. This only works if our dependency tree is clean, because um, if we link A and E together and we start linking around other dependency, then this will mess up caching. We will have a lot of cache misses, and then we would go back to square one. It doesn't matter if we have a cache, if our dependency tree isn't clean, um, it will not be improved. So a more concise example would be, a concrete example would be, there is nothing um, there's not there's nothing that would prevent a developer to import settings in checkout or checkout in settings. And I mean, they are not, from a functional perspective, they are not needed. However, um, someone could theoretically do that and the app would still build. However, we would increase cache misses and it messes up the dependency tree. And natively using Xcode, there is no way to do that. And but however, using the build system that we have, we can just add some assertion rules before building the project, and this will shift the errors more to the left, as in we will crash directly the build on the laptop even before we run CI, so developers are aware that hey, they imported or they used something they shouldn't, or if for some reason they pushed and didn't notice, the CI build will fail pretty fast, and we will not spend 20-30 minutes building and then to fail at the end. Again, since we have control over the project that is generated from the start, we can take advantage of that. So in terms, so scoping is another term we use to generate only what we are working on, and generating only what we need to be able to build only what we are working on. And since we have access to the build system, and since generating is just taking a bunch of files and generating an entire project, which would, even though it's cached and even though we're not going to build it entirely, it's going to still load in memory. It's going to still open in Xcode. So this is not ideal. However, since we already have a configuration files, we can use that and pick few files and just generate a scoped project. Maybe I want to work on checkout, I will generate only checkout. Maybe I want to work on a feature or experience, I will generate only that experience. So in essence, we use the same build steps. Instead of generating huge projects from many files, We just pick a few files and generate a small project, a small part of the project. Projects open way faster, use less memory, they are less heavy, and developers are way happier. I can attest to that. So let's go through an overview of the improvements we did. We removed conflict. We enforced dependency tree, which is really important. We built only what we needed, and most importantly, we load only what is needed, which is in memory when we generate a small part of the project. So, however, but what is the end result? Why did we do all of that? I mean, yeah, to make everything run faster, but for business, this is not enough. And for us, we dropped the build speed on CI by over 70%. So if you take a look at the blue graph, it is way less than the green one. Why? I mean, we didn't change the code. We haven't applied any of the improvements, any different improvements in code. I mean, we are always doing that. We are always doing what Eduardo suggested before. However, with only build time improvement, we saw 70% on average build time improvement. And the important key point here is because we are not building the entire app. We are building depending on what the developer changed. So if a developer creates a PR of only one line and a certain target that is used in one app, we only build that app, or we only build those targets. So we use the caching mechanism that we talked about, and it is a pretty huge difference. And if you are wondering why we have these spikes, these spike blue lines, those things are normal because we are going through re-architecting and refactoring a lot of parts of our code, of our core code, and essentially core code is something that is used by every app. So sometimes the entire app will have to be built, but this is normal. However, for most PRs, they are way faster. Some PRs take only 10 minutes, 8 minutes, 7 minutes, depending on the change. I'm gonna share some things we have for the future, what we're thinking about, and some side projects or side improvements we are working on. Those are still work in progress. We don't have a lot of demos for everything. One thing would be scoping. As we mentioned, that since we have configuration files and we can generate a small part of the project, our next step would be to generate an application for that. So QA and developers can quickly test and go through their changes rather than installing the entire app. The second thing we are working on is analytics, and Rafa is deeply involved in, which is we are checking whenever there is a cache miss on our build system on the CI. That's how we know, okay, this target is changing a lot. We are having a lot of cache misses. Maybe we can split it up more. Maybe there are some things that can be extracted from it that doesn't need to be there. So this is the next step. We're always working on fast testing, fast build times, and this isn't necessarily related to actual build times, but actual code improvements, separating stuff that don't need to be together, using interfaces instead of concretes whenever possible, and yeah, even more efficient development. Who doesn't like that? We're always reading, always improving, always trying to see what can we change. And the last thing I want to share is an internal CLI tool that we started using recently, and it's something that we are aiming to help as much as possible developers to interact with the project easily. Since we mentioned that we are using Twist, but we are good developers. Everyone here knows that in our apps, we usually always try to wrap and abstract any third dependency that you use. This goes as much as build improvement or generating the project as it goes in code. So we don't want our developers to be experts in Twist to be able to generate and use the project. We wrapped all of this up in a CLI tool, and we are adding additional functionalities like quickly generating new experiences. So we will go and generate all the files for the devs, generating new cores, and we will go and edit the configuration files so they don't have to learn how to use Twist, even though it is easy because it's written in Swift, but it is also an important point to mention. And that's all. Thank you for listening. I hope you have many questions for us.
Hey, normally when you start, you say that when you got here, it wasn't everything modularizer. Eduardo, I think, said that. But so when you're managing to go to more modularized and start using Twist, what is the first approach? Like, let's say you have a monolith, everything is one single file. You start with the core, and then you start growing up the Twist from that. How does it work, the first approach? Yeah.
So you mean when
Going.
Yeah, the kind of like the first phase when you're getting to a modularized architecture, because before it wasn't, right? And then you
okay.
start and
Yeah.
grow up, start using Twist, start using other tools. The first approach is what? What do you recommend that?
So I can tell you how was this at the beginning, maybe like 5 or 6 years ago. We didn't have any target. It was just a single target, the app target. And then we say, okay, maybe we need one target or a couple of targets because we wanted to build the application also for China. And China was a different application, not the adidas one. So I say, okay, we need a third target. And we call that mobile core. Not the brightest idea, I can say. Um, and then other applications came into place, confirmed, and we started to see that, hey, maybe we have like some functionalities that we can extract to different targets. We did that in a kind of generic way, like, okay, let's create like an UI target for the Adidas stuff. So we have Adidas UI for the core stuff, and now we have Adidas core. And that lived or worked for a while until we realized that at some point we were making like one change in one of these targets and we have to rebuild everything. And we have like a lot of files, not 10,000 files like today, but maybe 2,000 files. And at some point we say, okay, maybe it makes sense to extract or to split this split this down into experiences, or what we call experiences, which are just features. And then we came into this idea of layers, which is something like I think is common in other industries. Like, okay, you start to have like the presentation layer, the business layer, the data, then you may have third-party dependencies, so you can reuse all these components. But it's something that happened over time, not in like 1 week or 1 month. It take a while. It took a while. Yeah.
Yeah, and there isn't one way to split things or a set of rules to follow. In the end, you know what's there and what you can split up, and you just have to do it bit by bit. Try to split as much as you can, and whenever possible, also create target interfaces that do not change every time. That if you change the actual target, you do not build other things that depend on the interface. I hope we answered your question. I don't know if you have a follow-up.
Yeah, it did. I have a follow-up question, but that's okay. Or pass along. Okay. And how do you do the whole finance estimation? So the business part of, because
Yeah.
I saw the graph and it's quite nice after 3 years doing this, and then say, hey, it's 100,000. But when you guys starting, how do you say like we're gonna save 1 million 1 year, and how do you do the whole
No.
estimation?
No, this is actually, so if I go to the graph, spanned over a couple of months, and I mean, the price isn't going to change over a couple, like within 4 or 5 months, it's not going to change within the next 4 or 5 months. So we took, let's say, 3 4 months, and we did it times whatever we need to get to a year. And you can pretty much know that the price per build minute, and if the project takes that much time and you do on average, let's say 5 6 7 PRs per day, then you can pretty much get a good estimate on that.
All right. Yeah. Thank you.
Yeah.
Okay. First, just clarify. So this is just price built to paid to the build system.
Yes, through the CI.
Oh, okay. Yeah. I was wondering whether it was like we saved 3 developers per year or 2.
Oh.
Developers don't have to wait that long.
No, this is CI. No, we're talking about CI. The other one that is I mentioned, maybe I didn't make it clear, was the analytics one, is for developer analytics. So we also want to know how much it's taking on a developer's devices. This is kind of something we're looking forward to work on in the future. We are adding that, so we have kind of planned for it, and we're talking about it actively.
Yeah. Okay, I have another question. So you mentioned a couple of slides earlier, you have like the twist generation of your project,
Yeah.
and then you added caching, and then you added assertions.
Yeah.
And as I understood, the caching and the assertions are stuff that you built on top of twist.
Well, we leverage some things in Twist. So we leverage plugins for assertions to do dependency graph assertions, and caching is basically mostly Twist caching. We might be doing some things that are not 100% given by Twist, but mostly the entire thing is wrapped around Twist.
Okay. Okay, that's very nice. Do you have this written down somewhere? I mean, I'm sure Twist has success stories, but it's always nice to have like
No,
an actual story.
I don't think we do. I mean, we are in communication with the guys, but I don't think we do about this stuff because it's tailored for mostly for what we need, and some things might not be applicable for everyone, you know. And the dependency graph works. Dependency graph assertion works towards the architecture or the structure that we have. That some of it was shared by Eduardo before, you know.
Okay, so some of it is specific to your project.
Yes.
So this one only accepts this and this.
Yes.
Okay. Okay, thanks.
Someone else a chance for
Hi. I have a question about, so you used SPM for your third-party dependencies, and you also binary cache them?
Yes.
And how does that go, or what are your experiences with that? Is it also an expensive feature of Twist because it was paid?
Do you have an answer for that?
So you're asking about caching in
The
Twist?
binary caching of Swift packages.
The migrate caching of Swift packages. You mean
The cache.
binary? I heard migrate caching. Okay, binary caching. So yes, we started first with the Twist with the Twist one that was free and open source. Then there was a deprecation, and after that we have something around the deprecation and around internal caching a little bit. So it goes both ways. We are still on the old system. We have still using some of the old Twist versions, yes, and we have some stuff added from internally. So it's kind of a fusion, and obviously maybe I'm merging what you asked is whether we're gonna contribute more or release more to the Twist community. I mean, this is whenever we find there is something useful, something stable, obviously this would be the next step, right? But you don't want to introduce something that is too specific for a company that will not work, for a project, let's say, or our project, that will not work for someone else.
Yeah. But you have some kind of caching going on packages. You don't fetch the whole thing again every time you do a build, or?
So we do, but we also additionally have, let's say, how do you say, what is its name? The not JFrog, the Artifactory caching as well. So you have multiple layers of caching, whether it is downloading and then building, you know, and then all of that. All of that is working together.
Okay.
Yeah. Also, something that we try is, at least in the CI/CD side, is not to just cache the binaries, but to cache the SPM folders, which kind of works and it speeds up a bit the installation of the dependencies. And then we also use the Twist cache and all this Artifactory stuff.
And if I may add something, so there is always a trade-off in caching, whether downloading is actually faster than building. And since we are using for most of our builds, let's say Bitrise, so you always need to connect to your cache, and then this is over the network. So there is always a trade-off there, and we still haven't figured out when you do not have control over where your CI pipeline or CI worker runs, how to connect that efficiently over internet, not network. So there are a lot of things going on, but however, this is basically how it all works together.
Okay. Sounds really interesting.
Yeah, thank you.
One question which was not answered yet. So you how you say, check out the repo. You run your toist config thing. How long does that take to basically create the config file for the application and then build the application? Is that like the 4 minutes that is in the graph, or is it more like 8 minutes?
The total time it takes to generate the project plus build.
Yes.
So it is a bit more than 4 minutes because generating the project will be around
3-4.
no.
Depends.
Well, depends.
You need a
Depends.
faster computer.
No, it depends. Of course.
So we're talking.
Depends.
We're talking with generating and downloading. So, what do you mean about generating? Just generating the project?
Yes, you have everything online. You have everything, the repo,
A minute and a half.
and you just generated. You just generated the application,
Yeah.
and then you move one commit back, and then you have to generate the application back again because someone else might have changed something. So you have to regenerate the whole project, and that's a pain in the arse.
Do you know?
Still is. So yeah. So I was wondering about that.
It's a couple of minutes. I don't know how much.
Generating the project takes, if you start from scratch, it will be around 2-3 minutes because you have to download everything and then generate the project, and it takes quite some time. And then building the actual, if you are, for instance, building the app without any cache, like building just the things that we have in the repository, not third-party dependencies, will be around 4 or 5 minutes locally, M1, in an M1. And one and two.
But still is better than Xcode separate.
Yeah, it is. It is.
I have another question. So you mentioned scoping, which sounds very nice, but I also can also remember from a previous project, huge project, and they said, "Oh, you just create your own little app to test your view with," but that app had slightly more dependencies. It took me like several days to just figure out which freaking modules I needed just to show this one view, because nothing was documented, of course. Well, everything was documented in the code. And they used an even better build system. So how easy is it to create a minimal viable project? So let's say Adidas asked me, yeah, we need a new Korean product page. And I think, oh, I can do that. But how easy is it to do in your application?
If it's new, fresh, I think it's pretty easy because you decide
it has to fit in the application.
it has to fit, but then you have to. I think you have to surround it by different targets that are providing it.
But if you want to like create like a scope app for something which is already in the project, it will take a while because we have exactly that problem. That we don't really know which dependency we have to use, and so that's why it is in work in progress right now.
Yeah, because you need analytics, you need the network layer, you need the product layer, and you need the models and stuff like that. So okay, nothing ever changes. Thank you very much.
At least they have a system. They have a system.
We are not reinventing the wheel. Yeah.
Do we have time for more questions? Yeah.
Hey, thank you for your presentation. I was wondering, what tool do you use to help you visualize your dependency graph or help you debug your caching code that you applied? Like, I changed something in module A. How do I make sure it doesn't update C, D, and E? Like, how did you visualize it for yourself to verify the cache worked?
So currently, I don't think we have something like that. We know what are the dependency because they are clearly described in the configuration. However, do you think this is one of the things that is visible in Axiometric for us?
Not right now.
Not yet.
Yeah.
Not yet. We do not have that yet.
Cool, thanks.
Were there more questions? comments, ideas? No? Then thank you very much for the talk.
Yeah.